Hi friends, now let's continue our discussion on some old theory which we called the Markov decision process. Markov decision process is a mathematical framework for modeling sequential decision making under uncertainty where an agent interacts with an environment taking actions that lead to transitions between states and rewards. So that's a definition which fits to the reinforcement learning. But the older version of the definition says that Markov decision process is a decision process where the future state of the process depends only on the current state, not on the past history. So the core idea is that the next state of any system depends only on the current state, not on the history of the past states. That means we are at state A, then if we take some action, then our system will transit from state A to state B with no reference or with without any knowledge how the system came to state A. So whatever way it comes to state A doesn't matter, but once it is in state A and for a given action, it will move to state B. That is confirmed. So we don't need to know from which state it has come to state A, but once it is in state A for the given action, it will always move to state B, and such a system is called a Markov decision process, where the system is deciding which state to move further for a given input. So the goal of a Markov decision process is to find an optimal policy or a strategy that maximizes the expected cumulative reward over time. Yes, we know that for any reinforcement learning system, for any action, there will be change in state, and along with the change in state, there will be a reward. Reward may be positive or negative depending on the situation. So the goal of MDP is to find the optimal policy or the strategy that maximizes this expected cumulative reward over time. So we start from one situation and we keep on making some actions, and after some set of actions where our system will be, and on the way how much reward is generated, the total of these rewards needs to be maximized. So we need to identify the path that gives maximum reward, or finding the optimum strategy to get the maximum cumulative reward that is expected. So that's a major goal of our core decision process, and this exactly fits to our reinforcement learning, because even our robotics also, we want our robotics to be independent. We don't want to be always working on our programs, so it has to learn as and when it encounters new situations. So if it has to learn something from the encountered situations, then we want it to be reinforcement learning strategy to be applied, and that will ensure that we must follow the Markov decision process, because that's going to find the optimum solution. So the Markov decision process, so all the problems that can be classified as reinforcement learning problems can be addressed through Markov decision process. The challenging problems across the robotics domains we tried to solve using various techniques like fuzzy control, because there is no uh, deterministic way of working. So we wanted some fuzziness. So we tried with the fuzzy control algorithms. We tried a genetic algorithm to have this fuzziness, or to the genetic algorithm is a way to solve a bigger problem in a quite a short amount of time. So it's basically not a solving method. It's assuming the various number of solutions for a given problem and then identifying which of the solutions is most optimum, and that way we work on in the genetic algorithms. We would like to use neural networks for the same. So we can make use of the concept of particle swarm optimization or ant colony optimizations, or even simulated annealing algorithms. We tried many of them, but we could not make our robots learn on their own. But this all would give solutions for known situations. But when an unknown situation is encountered, definitely we would like to have a self-learning thing, which is what reinforcement learning is all about. So the applications of Markov model is we can make use of in reinforcement learning. So here we can train the AI agents to make decisions in the dynamic environments. Can be used in robotics for planning the robot trajectories and actions performed. Resource management, where optimizing the resource allocation in complex systems. In game playing, while developing AI game playing strategies, we can make use of them. So the basic question is why we would like to use reinforcement learning for robotics. First thing is reinforcement learning is one which learns through experience. It is adapting to the uncertainty, and it is always taking the optimal decisions, and handling high dimensional data is quite easy in reinforcement learning compared to other, as we discussed in the previous slide, like fuzzy logic or the genetic algorithm and other such things. So when it is high dimensional data, then it becomes easier for reinforcement learning to work on. So it will be easier for controlling the motors and manipulations and all that. So the maneuvering the activities of the robot can be learned as a child learns to move the hands and legs by uh, doing itself. The same logic we would like to apply for the robots. They would like to make their own movements and learn through their own experience whether the movement they made is right or wrong, and if it is right, next time similar movements are encouraged. If it is wrong, the similar movements are discouraged, and so on. And most important thing is it can be highly useful when it comes to autonomous exploration. So we don't have to write a code for a robot for exploring and all that. So it can explore on its own, and while exploring, it can learn, and that way it will be quite easy if we apply reinforcement learning for robotics. And multi-agent collaboration is quite easy when it comes to reinforcement learning. So multi-agent collaboration in the sense that when multiple robots are trying to work in unison, then it becomes easier for them to work collaboratively and with less friction. So that's the advantage of working with reinforcement learning in robotics. So many more things like more details about reinforcement learning and types of reinforcement learning and how that can be applied to robotics are on the way. So please keep watching. Thank you.